Okay, so this is the second day of 6.3, so we're still working with roots, and our goal for today is to simplify and evaluate these radical expressions. Okay, so we're going to be talking about rational exponents. So rational is another way to say fraction. When it says you're going to write something with a rational exponent, it means the exponent is going to have a fraction okay, and then one of the main things we're going to talk about today is this form. So the exponent 1 over n means the nth root. So if you have 16 to the 1/4, that's the same thing as the 4th root of 16, and then that can simplify to 2. Okay, so in general, it's a to the power of 1 over n is the nth root of a. Okay, that works with any of your powers. So if you have the square root, that is the same thing as a to the 1/2. That's the square root of a. You have a to the 1/3. That's the cube root. You have a to the 1/4. That is the 4th root. And that pattern continues. Okay, so anytime you have 1 over n, n is what is called the root. Okay, and then the other equation you can have, m does not have to be a 1. So here you can see it was a 1. We have other exponents. That is the nth root raised to the nth power. Yes, so the nth root raised to the nth power. Okay, so the example they give you is 8 to the 2/3. You can write that as the cube root of 8 squared. The cube root of 8 simplifies to 2, so you square the 2, and that is 4. Okay, so with that, we need to remember that the denominator of the rational exponent becomes the index or the root of the radical. Okay, and we can write that 2 different ways. So you have a to the m over n. Okay, we are going to use both of these methods. When you are trying to simplify, you are going to be using the nth root of a raised to the power of m. Or you can also do the nth root of a to the m. So the position of the radical or the position of the power can go inside or outside. The power can be applied inside or outside the radical. Okay, and we'll go over situations where it's beneficial to have it outside and others where it's beneficial to keep it inside if we have to do some simplifying. Okay, and we know that this section is really heavy with a lot of rules. So sometimes we can second guess ourselves. It might be hard to remember which one is the power and which one is the root. So I came up with a way that helps me remember, and you guys are welcome to use it. So if it's a root, I think of trees and how they have roots that grow in the ground. So that's how I remember that the root is on the bottom. Okay, roots grow in the ground, so the root is on the bottom. Okay, the power is on the top, so I draw a little crown. Because if you have the power, you are on top. That's right. Okay, so that's something I use to remember, like if I'm second guessing which one is which, the roots grow in the ground, the power's on top. Okay, so in the first example, we are going to write each expression in what is called a radical form. Okay, and so we're going to do x to the 3/4. We're going to do y to the 1/4. Oh, and then I am going to add like a C and a D. So let's actually, we'll move this over. We'll move C over a little bit. We'll put C here, and then we're going to put D here. C is 2xy to the power of 2/3. And then D is 27b to the 4/3. Okay, why don't you guys do B real quick? Why don't you guys do B real quick? So you've actually already done something like that. Okay, so if it's y to the 1/4, remember we just talked about if it's a to the 1/4, it's just going to be what? 4th root of y. Okay, a actually has two answers, so you can write it like this. You could write it as the 4th root of x cubed, or you can write it as the 4th root of x to the power of 3. Okay, either one of those are fine. Okay, so there are two different ways you can write it. The power can either go inside the radical or outside. Okay, and then for C, okay, this is the cube root of, and then this one we're going to want to do inside because there's a number. When you have something in parentheses that is squared, you have to distribute the 2 to everything inside. So 2 to the power of 2 is 4, x to the power of 2 is x squared, and y to the power of 2 is y squared. So this is going to be your final answer. Okay, now all of the fractions we've had that are exponents up to this point, 3/4, 1/4, 2/3 are different than 4/3. Do you guys know what's different about it? The what? What do you mean it's the opposite? Okay, yeah, it's greater than 1, right? It's an improper fraction. Okay, so the improper fraction is going to lead to some more simplification. So when that happens, we are going to have to do some simplifying. Okay, what we're going to do is we're going to separate these, and we're going to do 27 to the 4/3 times b to the 4/3 because it's a little easier to separate the number by itself. And if this is another no calculator unit, so we're going to do this without a calculator, which means you're going to want to do the cube root of 27 and then raise it to the 4th power. Okay, what's the cube root of 27? 3. 3 to the 4th power is 3 times 3 is? Yeah, it's 81 because 3 times 3 is 9 and 9 times 9 is 81. Okay, now here you would have the cube root of b to the 4th. This is exactly what we've been working on, right? So 3 goes into 4 how many times? Once. So 1 comes on the outside, and then you have 1b left on the inside of the cube root. Okay, so if there is an improper fraction, that's when you're going to have to simplify. All right, nice job. For example 2, we're going to write each expression in radical form and then simplify. Okay, so we're going to do negative 32 to the 3/5, 64 to the 1/3. Let's try those two. Okay, so the first thing you're going to do is rewrite them with radicals. Okay, so the radical is always the one in the denominator. So we have the 5th root of negative 32 raised to the 3rd power. Okay, what's the 5th root of negative 32? Negative 2. Negative 2 to the 3rd, negative 8. Okay, so that's going to be your final answer. Okay, this is the cube root of 64. Some of you are going to know that right away. Okay, others might have to factor tree. So if you have 84, you know it splits up into 8 and 8. And then we know 8 is 2 cubed, right? Okay, so if it's the 3rd root, you need 3 of them in order to come outside. So if 2 2's go outside, what does that make? 4. Okay, so that's your final answer. All right, now we're going to do one with a variable. So we have 4x to the power of 5/2. Okay, again, notice that you do have that improper fraction. So what we're going to do is we're going to split that up into 4 to the 5/2 times x to the 5/2. Okay, so I want you to see if you can simplify those. Okay, so then what we should have done is the square root of 4 raised to the power of 5. Is that what we did? Because the 2's on the bottom, so it's the square root. So what's the square root of 4? 2. What's 2 to the 5th? 32. And then here you have the square root of x to the 5th. So 2 goes into 5 how many times? Twice. How many are left over? 1x, so that's left inside. So your final answer, 32x squared root x. Okay, now the last one has a negative exponent. Whenever you have a negative exponent, remember there is a nice little rule that says if you have a to a negative exponent, to make it positive, all you have to do is put it over 1. Use the reciprocal. So that's what we're going to do here. This is 1 over 625 to the 3/4. And that is 3/4. I know that's probably hard to see. Okay, so then from there, we can do the 4th root of 625 raised to the 3rd power. Okay, again, some of you might recognize the 4th root from what we did yesterday, but it's okay if you don't. If you have 625, you know that 5 goes in there because it ends in a 5. So you can just divide that by 5. What's 625 divided by 5? 125. And then, so when you're dividing by 5, 125, you know, is 5 cubed, or 5 times 5 times 5. Okay, so you have a group of 4 5s. So the 4th root of 625 is 5. And what is 5 to the 3rd? 125. So that is going to be your final answer. Okay, 1 over 125.